Welcome everybody to a practical introduction to machine learning with Databricks Mosaic AI. We're really happy to have you here. Personally, I'm very, very excited to, I think, get the chance for about the first time in about 18 months to talk about machine learning. So hopefully you're as excited as I am about the opportunity to kind of revisit something that was probably important to all of us before November of 2022. So quick statement on the classic caveats, if you will. We're going to talk about a lot of cool stuff. Don't go trading stock dependent upon what you hear, and don't count on the fact that everything we say, you can't hold that against any of us in court of law or what have you. So there are two of us on this talk today. Myself, Craig. I run product management for AI and machine learning at Databricks. Previous to Databricks, I was at Google, where I built Vertex AI, and then previous to Google, I was the founder of SageMaker at AWS. So, really excited. This is an area. Thank you. It's an area that's extraordinarily important to me. The idea that we can help organizations make more efficient decisions is extraordinarily important. To do this talk with me, I wanted someone who could do unbelievable demos. And so I went to the person who was one of the best demo people. You guys probably know the bar for demos on our team is quite high, given Cookie Lady yesterday. And so, it was a similar view of I needed someone really good, and I went and I asked, and they said no. And so I went to one of the smartest people on the team, and they also said no to me. So I went to one of the better looking people on the team, and when I got to him, he said, "Craig, I've said no to you twice already. I guess fine, I'll do it this time." So I'm excited that Nick has been a part of this, but unfortunately, Nick texted me about an hour and a half ago and said he had come down with a terrible, terrible cold. And so alas, despite his playing hard to get, he has played unbelievably hard to get, and you're going to have to deal just with me today and some videos of Nick. So bear with us. So why are we talking about ML? Right? In a world of Gen AI, in a world that's running towards AGI, why are we talking about ML? And for me, the reason is that we collectively, not even collectively, even individually, some of us have spent decades curating our business's data into bronze, silver, and gold tables, and really isolating the key metrics and the key features that we might need. And because of that, we have this treasure trove of opportunity inside our businesses to extract value from this data, right? These are very low-cost methods, what we're going to talk about. They're concrete, they're easily measurable. I can tell you exactly how accurate your model is, which, if you've been going through the last 18 months, is a weird idea recently, right? So I can tell you exactly how accurate your model is. There's millions, and for likely many of you, even billions of dollars of opportunity, right? You get one good forecast that removes a couple percentage points of error from your previous forecast, and all of a sudden you're saving on labor costs, you're saving on material costs, you're able to go capture opportunities you wouldn't have been able to capture. And then finally, it just continues to get easier over time. Innovation drives greater simplicity in this space, and so we're able to do more and more. Now, what blocks us from doing this? Right? It requires a highly skilled team, and it requires a team. Usually it's not enough for just one person to be able to do this, right? Most companies are talent constrained, right? It requires connecting multiple complex systems, right? How am I going to get my data system and my AI system and my DevOps and my applications, kind of server application stack? How am I going to align all of these, right? And then it also, moving to production can sometimes feel impossible, and sometimes it is impossible. And then obviously maintaining these models over time can be a challenge. I remember right in the heart of COVID, I met with one of the leaders of one of the larger retailers in this country, and I said, "Hey, when the pandemic first hit, how did you guys figure out which models to go prioritize retraining first?" Because when the pandemic hit, we all thought that, toilet paper was more important than gold. And so these models wildly changed in the way in which they predicted human behavior. And so I said, hey, how did you prioritize which models to go retrain first? And the person just looked at me and embarrassingly laughed and said, Craig, do you think we even know where all of our models are? Right? And that just can't be the answer anymore, and it doesn't have to be. Now, today, what I'm going to walk through is actually a solution that was designed to bring data engineering, data science, ML engineering, and DevOps together on one set of tooling, right? No longer requiring kind of this moment where the data engineer says, hey, I've got the data ready for you, and the data scientist says, cool, put it into my feature store. I don't use your systems, I use my own systems. And then, the data scientist finishes and turns to the ML engineer and says, put this in production. The ML engineer says, oh, you use those columns in the feature store again that we don't have in prod. I have to go find some other similar, feature in our prod stack in order to feed your model. Probably have to retrain your model too, right? And then they hand it to DevOps, and DevOps is like, well, I'll watch to see how much memory and CPU consumption you're using, but all these other the metrics you might use to measure model quality over time, skew and drift and SHAP values, I'm not going to look at any of those. You need to, right? And so these four groups have often been almost in contention with each other. I've worked with companies where the data science team and the ML engineering team were not friends. And my hope is that, yeah, exactly. My hope is that if we can find a common set of tools and we can find a common workflow, we might be able to start finding empathy between these groups, and we might be able to use that empathy to drive velocity. So I would argue that almost all the AI platforms out there are broken. And the reason why they're broken is because of this. It's siloed ML. These are standalone services, right? The AI ML engine doesn't even know what data is, right? Data is a foreign concept, right? It's some input that you bring into the system, but the system doesn't respect that data. It just chews it up and finds the patterns and gives you some model weights. And I think there's a better opportunity, right? This idea that I invest in my data stack and I get governance and I get lineage and I get all these things, and then I build an AI model and I govern it and track lineage by putting it in Excel and hopefully tracking across the list of models I have. This can't be the solution. And so what if the ML platform and the data stack were one system? Now, we're at a conference that's called the Data and AI Conference. I lost the ask, right? I just wanted it to be the Data AI Conference. I didn't want that "and" in there. I didn't want this idea that these are separate things. I wanted them to be the same thing. And I think that's what you're going to see over the next few minutes we're trying to achieve here at Databricks. So this opposite idea, right? An ML platform built inside the data layer, right? Common tooling for all of the personas, right? End-to-end governance, not that ends at your data, but then goes through your modeling, out into your model in production, and then, even as you're monitoring your model, that's all part of that lineage train, right? A single copy of your data, right? Models that just simply inherit the governance of the data they're trained on. Very often when I get called into customer meetings, the kind of salespeople will say, hey, I've got you a meeting with their head of AI or their head of ML, and I'll be all excited, and I'll say, hey, can you invite the head of security or the CISO too? And they'll look and go, oh, Craig, they're not a friendly of ours. Like, don't talk to them. And I say, no, invite them. Trust me. And I invite them in, and they see this idea that the model simply inherits the governance of the data it's trained on. And they start to realize that these artifacts that we create off the data, these artifacts don't have to be a threat in quite the way we've all imagined them, right? If I've invested to secure my data and then I have a model that is free floating that anyone can use, let's be honest, these models, if you know what you're doing, you can get them to regurgitate the data. And so how do we avoid that, right? And we avoid that by having a common governance stack. And then obviously leveraging the lineage and the semantic understanding. You could imagine that if you were training a model, and let's say you had a primary key and you had an objective function, what if you also knew every query in your company's history that hit those two columns, and what columns of data they included when they looked at when folks queried those two columns? What other columns did they query? Right? Now all of a sudden we can start to say, whoa, that's all easy, by the way. That's a quick query of our system tables at Databricks. And now all of a sudden you can sit there and say, hey, these tools, this semantic, this lineage, it's not just a cool audit artifact. It actually can help us drive model performance. It can help us drive business outcomes. So with that, what would that get me, right? Increased productivity, ease of discovery, ease of deployment, increased model quality, right? Increased model ROI, better safety and governance, all of it. So this idea of unifying, and I say unifying because you're about to see that, for me, this entire thing is about the Unity catalog. My goal with machine learning is actually to get our services just to disappear into the Unity catalog, right? This idea, and the reason for this is because the Unity catalog is a really special catalog. It's observational in nature, and those of you who have been practicing data scientists in the past, I'm sure you've had the experience where you're pulling some data and it's not quite right, and so you're pulling some more data and it's not quite right, and you're pulling some more data and it's not quite right, and you get to the end and you finally got the data that's the data you need. And you look back and you say, I don't know that I could recreate that. We tracked all of it for you. We can recreate it for you, right? That you don't miss this opportunity. If you trained a model and someone says, whoa, I don't believe this model, and you go to retrain it, but you realize, wait, I can't retrain it. The data in the underlying tables has changed. Well, with Unity and Delta, you can just rewind that table to the last time and date that you changed to show them as you retrain it that you didn't make a mistake, that this is what the data showed, right? These are monumental kind of capabilities in our space. So let's talk about how can a catalog be central to ML? Well, it's a unified workflow that I'm going after. And if we start with Unity Catalog, these are all the bits that we're going to include as we kind of walk through this workflow. So what I'd like to do now is spend some time walking through the workflow and giving you a sense of how we think about developing ML models in the most simple, most governed way, I think hopefully anywhere within kind of machine learning platforms today. So first of all, we have to ask ourselves, what is a feature store, right? This is one of the first things up there. What is a feature? Well, feature stores they're a data catalog, but they're a specialized data catalog. They're a special data catalog for AI and ML systems. And so they need to make it so that you can discover, organize, find your features, maybe manipulate them, maybe build new features. But they also have two other requirements. They need to be able to serve those features to high-performance training systems and high-performance inference systems. And so the problem is that these feature stores, they create duplicate data, right? They break our lineage and governance when we export the data from our system into the feature stores. They often require complex efforts to bring in new data, and they often require an additional system to learn and get integrated for the users, right? The users now have to probably go learn our data warehouse, and they have to go learn our feature store. And so what's the alternative? Well, for us, we took a feature store that we had built, and we just ripped the back end out of it and made it the Unity catalog. So today, any table you have in the Unity catalog that has a primary key can be a feature table, can serve features. Now, one of the great things is that with Delta Live tables, right, you can build your own custom features, right? Very often the table that we see in the data warehouse isn't actually what we need. We might need to do some transforms. We might need to do some data cleaning. We might need to do some data validation and some pre-processing steps. We can build those pre-processing steps into a Delta Live table using Python, using SQL, and then all of a sudden we have a repeatable kind of pipeline pushing towards a feature table that we're ready to use for our model. And so with that, I'd like to actually have Nick now join us from the video to give you a demo of what this might look like.
All right, hi everybody. Sorry I can't be there today, but you're in great hands with Craig. I'm going to just show you kind of a few different parts of what things look like in the actual product, and we're going to start off with data and feature engineering. So just like a typical machine learning workflow, we could go in here and start writing Python and just write it in a notebook and maybe schedule that notebook. But what we're helping our customers do is actually create more robust pipelines. And so what we've done is we've actually created a Delta Live Tables pipeline. So if we go over here and we go to our Delta Live Table, you'll see that we've actually defined an end-to-end data engineering pipeline, and we can actually run this to see how this works. Basically, Delta Live Tables gives you a really robust way to set your data up for multiple training and retraining cycles. So oftentimes, you're not going to train a model one time. You're going to need a pipeline that's constantly ingesting data and sets it up in such a way that you can constantly be retraining your models when you need to. Here we can do really cool things too. For example, we can set expectations, which enforces a certain data quality on tables. So for example, for our gold table here, if we go to data quality, you'll see that we've set some expectations to drop any data where nulls come in for these 3 different keys. Now that's going to be important because if we go actually see where all of this data ended up, we can go to our catalog and we can actually go to retail prod here, default. You'll see that we've materialized our data into feature tables. Now, part of this materialization, part of the awesome thing that we do is that your feature table is just like any other table. The only thing we enforce are primary keys. And so that's why we set a data quality constraint in order to make sure that our features come through and our feature table looks good. So with that, I will pass it back to Craig.
Thank you, Nick. I guess that's weird to say, but thank you, Nick. So this idea of a unified workflow, right? It starts with our features, where that data is coming from Unity catalog. We may be massaging it, we may be pre-processing it using DLT, and then ultimately kind of saving it as a feature table, right? So from there, it's time to train a model, right? And with that idea of trying to train a model, we have really 2 methods that we kind of enable users to do that with. We have a code first method where folks, and this is by far the most common, folks will go into our notebooks and use any library they want, right? Maybe you want to use TensorFlow or PyTorch, or maybe you want to use XGBoost and or scikit-learn or something like this, and they can build their model within the notebook. Everything they're doing again is tracked, so that we know, hey, these are the steps that were taken, and here's what was done, and here's how we would need to reverse it if we needed to, right? And then as these experiments start getting built, as they start running experiments and training different models and stuff, all of that is getting tracked by MLflow, right? I think yesterday they mentioned 200 million annual downloads of MLflow. We are extraordinarily humbled by the place MLflow now takes in the kind of ML ops space as really probably the most downloaded and most used ML ops framework in the world, and we're really excited and proud of that. Now, you're not limited to that code first method. We also have an AutoML capability that's deeply integrated with MLflow as well, and you can do regression, classification, forecasting. Now, the difference here, is that unlike a lot of the companies who kind of do AutoML as their job, we give you the model, right? We're not protecting it behind an endpoint and charging you a lot to get to it. No, we give you the model. We actually expose every single trial run we did. And we give you the notebook, right? So you can sit there and say, hey, I really liked this version of the model. I was really impressed with some of the model metrics. Let me open up the notebook, see what they were doing, and see if there's anything I could add or improve here, or if I just want to use it as is, right? Now, not only, once you're done training that model, it's time to go and register that model. And now for us, our model registry, in the last couple of years, we've rebuilt it so that it is now the Unity catalog, right? So the same tools I use to govern a table are now the tools that I can use to govern a model, right? Our models can simply inherit the governance of the data they're trained on. And now, because the Unity catalog is our feature store, every model now has the opportunity to be a feature, right? It's that easy, right? It doesn't have to be some sort of miserable world of, Flask and all these kinds of things getting banded together to make it work. It can just work nicely when you start to unify all these capabilities. So with that, I'm going to pass it back to Nick as he'll go one step deeper for us.
So with our features ready to train a model, we could go and start writing some boilerplate code, like many have probably done before, where we can go ahead and train a model, right? But today we're going to do something a little easier. So on the left-hand side here, we're actually going to go to experiments, and we're going to create a new AutoML experiment. We're going to use serverless for this one. As we said, we are shifting everything to serverless to make lives easier for our users. And in this case, we want to train a forecasting model. So we're going to go find the tables that we just created, right? And so in this case, retail prod, we go to default. And in this case, we are going to pick our feature table, right? And select. We're going to give it a prediction target. In this case, we want to predict sales, a time column. We do have multiple stores in this data, and so we're going to give it a store ID and the forecast horizon and frequency. We'll say 10 days. And now we can launch this experiment. Now, we're not actually going to run this because it'll go for a little while, and we've actually already run this experiment. So let's go and take a look at what this looks like. So if I actually go into our experiments, and you'll see I've ran a few already, but what AutoML does, which is really awesome, is that it gives you not only the end model that it trained, but it also gives you the notebook that it used to train said model. So we can actually go and understand exactly what was done, what the training code looks like, and it even gives you really cool things like showing you the forecast. Wow, our sales are forecasting to go pretty far in the negative direction. That's probably not good. So let's go ahead and register this model so that we can share it within our organization. So if we go back to our experiment, what we can actually do is we can go to this model. Thanks to MLflow, which both tracks it and registers it, we can go to the top right and we can register this model into Unity Catalog. So we just need to run this little snippet of code right here. So what this is going to do is it's going to register our model into Unity Catalog under the name Forecasting Model. So if we actually go to our Catalog Explorer and we look at default, so we're in our catalog, we can go now to Models, and you'll see that we now have a new forecasting model. This model is now versioned, and we can even alias this as our champion model, since it is our first model. And now we have trained a model. Now, there is some magic to the fact that we registered this model into Unity Catalog, which is that it inherits, by default, the permissions of the catalog and the data that this model was trained on. So for example, if I want to grant specific people data, for example, all of our business users, I can go at the catalog level and I can grant permissions to all business users, right? And we can either do fine-grained or just all privileges, and we can hit grant. And you'll see that business users now have not just permissions to our model, but also to our data, simplifying governance for both your training data, your inference, and your models.
Thanks again, Nick. So, basically what we do here is we now take this unified workflow and we add to it AutoML, where the data starts coming out of, our features start coming out, and we start reporting those models back into the Unity catalog. We're doing some model evaluation, right? We're checking to see which models we like most. We're comparing the outcomes of each of the experiments. And then ultimately, we're registering that model, right? And we're governing it and taking full care of it. Now we move to the really exciting moment. Come on now. Now is the exciting moment, which is where we start to gain value from the data, right? Up until this point, this model is a cost to our company, right? This model is not creating value at this point. It took a bunch of people and some compute to build it, but we don't actually have any sort of kind of business benefit from the model yet. But that's why we're going to now put it in production. Now, we really simplify this process, as you can see here. So ultimately, it's really easy to go put a model into model serving. It's a simple API call. You identify the model, you put it, you basically line it up, put it behind a serving endpoint. If what you need to do is get that model up quickly and have someone that can hit that endpoint, right off the bat, then go for it. Do that. But it's actually not what we recommend. What we recommend is deploying the model code as opposed to deploying the model. And the reason for this is that we're not actually looking to deploy that model. That model is going to go stale at some point. And when that model goes stale, or when we get new data that might improve the quality of that model or help us make better predictions, in that case, we want to make sure that we can have it retrain all by itself, that it can just take care of it. That's part of why when we started out talking about Delta Live tables, instead of just saying, hey, write yourself a SQL query and that's your feature, right? What we wanted to do is we wanted to start with Delta Live tables so that we have this as part of a robust deployment, right? So that we can not just deploy the model itself, but we can deploy instead the ability to build the model, right? And so this is what MLOps Stacks does. MLOps Stacks is a capability that's built deeply into our workflows system and our new data asset bundles. And what MLOps Stacks does is it uses both that as well as code as infra to spin up all of the necessary pieces for you to be able to deploy this model and then rerun the training jobs whenever is needed, whether you schedule that, whether you have it set on kind of alarms or what have you, or based on model performance, or whether you just want to go hit the button when it makes sense to you. And so this idea of kind of like, hey, the feature engineering pipeline, touching the ML training pipeline, hitting our testing, and then going into retraining the model, validating it, and ultimately serving it. Now, whether or not you want to serve that model on day one as the new model, or whether you maybe want to serve it maybe and give it 10% of traffic, or maybe have it look at all your traffic in a shadow environment and see how it's actually running against production traffic. You could run it in that shadow environment. You could run it in that 10% or 20%. You choose what level you want to split the traffic at until you gain the confidence that that's the right model for you, right? MLOps Stacks really simplifies this whole experience by making it easier to create and manage this whole MLOps infrastructure when deeply connected into Databricks, right? You can easily set up these CI/CD workflows and integrate them with your CI/CD systems, and you can run a lot of this on Git as well if that's the way you guys manage all of this. Oh, sorry, Slack wants to tell me something. And then this can be used. MLOps Stacks. It's open. You can use it as is. You can use all of our defaults, or you can go extend this. Extend it more deeply into your own CI/CD systems. Extend it towards your app stack. Extend it in any way you want. It's completely open and modular. You can do with it whatever you want. We're really excited to see some of the customers who tell us about moving from kind of like weeks to days, or even from days to afternoons in the kind of time it takes to get a model built and into production. So from Stacks, we also have simplified serving. When I got to Databricks, they were excited to go build a serving stack. And I told them that I wasn't sure it was a good idea. And I told them I wasn't sure it was a good idea because I had built one at Amazon and I had built one at Google, and I had seen how hard they were to build. And I had seen that kind of we had to throw more and more people after these things to keep them up and running, to have them perform, operate at the highest levels of performance. And I was nervous that that was going to suck all the wind out of our team, and the only thing we'd be working on is inference. Well, we launched it, I should say, and we launched a much more simplified, much more dare I say, performant version. I couldn't be more proud of the team. Instead of asking you, hey, here's a list of 75 different VM types, which one would you like to use? I'll tell you that decision that you are forced to make when deciding kind of, hey, I'm going to use this SaaS model serving stack, and there's very few people in the world that can look at a model and all of a sudden pick the ideal machine shape for that model. If you are really good at that, call me, we should probably talk. But, so we asked ourselves, how could we simplify this further? And what we realized was the actual question we needed is just, when we auto-scale, how big do you want us to get, right? And so that's what we ask. We ask you, how big do you want us to get? And then we ask you, do you want us to scale to 0? We also scale really quickly. We scale, instead of it being 5 or 6 minutes before the next VM comes on board, it's usually about 30 seconds or less. So really exciting to get to see this. This is now the fastest growing product within Databricks, is our model serving stack. So this all comes full circle with Lakehouse monitoring. Once I've got that model in production, I need to make sure it's performing the way I expect it to, right? And that's what Lakehouse monitoring does. It watches the SHAP values, the skew, the drift. Now the great thing about it is it actually publishes a table of all of your model inferences, right? And then what it does is it just runs basic SQL window functions over those to calculate all of these different metrics. What that means, though, is that you can join things to that table. Let's say you know the ground truth. Or let's say you know the business outcome of each inference. Hey, did they buy the thing or did they not buy the thing? You can join that to the table now, and all of a sudden, you're not just looking at, hey, is this model performing according to the kind of data science metrics? You're seeing, hey, is this actually making a difference to my company? Right? And then if that model does start to misbehave, you're not limited to us saying, hey, your model's misbehaving, come fix it. Instead, we're going to say, hey, your model's misbehaving, and let's run monitors on your feature tables. And hey, your model's misbehaving. It looks like feature number 7 over here has more nulls in it or is broken in some way. And so, that lineage, again, the ability to leverage that lineage to go back, now all of a sudden, instead of saying, hey, the model's not working the way it's supposed to, we're going to say, hey, the model's not working the way it's supposed to, and we think we have the root cause already. Now that lineage that we read backwards, we can also read forwards. And what that means is that as soon as I know it's feature number 7, I know feature number 7 is also in this load job for this other table. I also know it's in these other 2 AI models. And I know it's in this dashboard one of our executives just looked at. So instead of this being model monitoring, it's Lakehouse monitoring, right? It's monitoring your model, it's keeping track of your features, and it knows the entire blast radius of the problem if there is one, right? This is the kind of thing that you cannot get from an AI platform, right? You have to have an integrated, unified system in order to do this. Let's take a look at Nick giving it a run.
We're not quite done yet. So if we go back to our model, we're going to need to actually, let the rest of the people in our organization use this. And so we're going to just serve this model with Databricks model serving. What this is going to do is forecasting model is it's going to let us put our model behind an API that lets us easily query it from various different either third-party tools or within a SQL query or within other notebooks. We're also going to enable inference tables. This is very important because what inference tables lets you do is it logs your payloads so that every time somebody queries your model, it tracks both what was queried and also the results. And then we can lay Lakehouse monitoring on top of these inference tables to get a better understanding of how our model is evolving over time. Are our features drifting? Are our model predictions changing? It gives you really good insight into when you may need to retrain your model. Now, once this model is actually deployed, we can query it either through the browser, but we can also just implement it as an API through any third-party front end that we want to use. We can also use it in Python. So if we want to embed it into a notebook or use it to create further features down the line, we can do that very easily. And now we even have this new AI query function within DB-SQL that we can actually query any model that is hosted on Mosaic AI model serving right in the query editor right alongside your data to make it super easy. Now, let's imagine that we've made some changes to the store, right? And we've deployed all of this pipeline, both the featureization, the data prep, the model training, and the deployment. And we need to run this now to see if our changes to the store have improved our forecasts. So thanks to MLflow tracking, if we are to rerun all this experiment, you'll see that it will actually, it'll keep track of it all in the same place. We can actually go to the source training run. We can see the new training history. And let's go ahead and exit this. And now you'll see, if we go to the bottom, that our newly trained model shows our forecast is going up. So now we'll be able to accurately track how all of our sales are, all the things we need in order to create whatever product that we're selling. Now, we do need to do one more thing. With this new model, we would like to, so we're gonna stop here. Now, just like before, we've trained a new model and we've registered it with the same name in Unity Catalog, and now you'll see that we have a version 2 of this model. We can alias this as our Challenger model. And now we can do something really magical. If we go back to model serving, we can go to our forecasting model, and we can actually edit this endpoint. And here we can do something really cool. So we can add another served entity. And we're going to choose actually the same model, right? So if we actually go to, there we go. We can confirm, take the same model, and you'll see now we have version 1, which was the originally hosted model, but we also now have a version 2. And what we can do is we can do automatic traffic splitting. So if you want to make sure that your new model is actually better than your previous model and more accurate, you can actually host both of them behind the same endpoint. That way you don't have to change any downstream code. What this does is it lets you A/B test, and all of the, again, the payloads get logged to these inference tables. So if we update, now what's going to happen is you're going to have 2 different model versions behind the same endpoint that you can now actively test and make sure that your new model is valid and it's better, and then push that into production and push that all the traffic through the new one once you're good. So with that, back to Greg.
Thanks, Nick. So, yeah, thank you very much, Nick. I'm sure you could hear that from there. So this unified workflow. With MLOps stacks, we've now gotten ready for our CI/CD deployment. We've got the model in model serving, where it's been pushing to model monitoring, and model monitoring is tracking the features, it's tracking the model, and it's reporting it all back to Unity. This is the power of this system, right? A data catalog that is your feature store. Everything is governed. Leveraging metadata to simplify and automate everywhere we can, monitoring the entire stack. It's ML building the way you'd want to do it, the way you'd want to build it. So what comes next? Building more intelligence and automation into every step, ensuring that we're using your metadata the best way we can to simplify these systems for you, right? How can we assist in things like feature discovery, training better models, right, et cetera? This is what I'm excited for as we look towards next year's Data and AI Summit. With that, thank you very much for attending.